Alright, 7th grade pre-AP. Hopefully you're taking good notes on this one because this is really important. We're going to be talking about proportions. Alright, proportions are going to drive our next few lessons when we talk about similar figures and other things. So make sure you understand this. Proportions. All a proportion is when we have those two ratios before our last lesson, when we have two ratios and we equal them. That's what a proportion is. So when you have two ratios that are equal, that's called a proportion. Now, here's an example. 3/5 equals 21 over 35. Those are two proportions that are equal. The way I got to the other one is if I reduce this one by 7 on each side. So if I divide this by 7 and divide this by 7, I will get 3 over 5. And because this is the same as this, it's considered proportion. Those are proportional ratios. And that's how you say it. They're proportional ratios. Alright, if two things are said to be proportional, then their properties when compared are equal. Kind of like a while ago when we had 3 over 5. Well, the properties of that one thing was 3 and then a 5. We're comparing those two numbers, 3 to 5. And the other one was 21 to 35. Well, if they're said to be proportional, then those two things are equal. Let me show you an example using shapes. Here's two rectangles. We have one that's 2 by 6 and one that's 4 by 12. Well, the properties of this one rectangle right here, we would say would have a width of 2 to 6. And this one would have a width of 4 to 12. Now we can rewrite this. Instead of putting 2 to 6 and 4 to 12, we're going to write them as proportions. So let me get a different marker here. This one is 2 to 6, and this one is 4 to 12. We want to see if these are proportional. In other words, we want to see if comparing these two numbers is the same thing as comparing these two numbers. Let's check it out. If I reduce 2 over 6, that's going to get me 1/3. If I reduce 4 over 12, that will also give me 1/3. Since these are the same, then these two rectangles are proportional. And that's all we're talking about. Now let's do another one. These are two weird triangles. Let's see if they're proportional. Well, this one is 3 over 6. Now, I cannot do this, 2 over 1, and see if they're proportional, because they won't be. And the reason why is because we're not using the same numbers on top and the same numbers on bottom. So they have to be proportional sides. They have to be the same sides that we use. So I have to actually rewrite this one as 1 over 2. And that's really important that you make sure you do that. Well, 1 over 2 is already reduced, so let's see if we can reduce 3 over 6. 3 goes into 6. 3 goes into 3 one time, and 3 goes into 6 two times. It reduces. So these two triangles are considered proportional. Let's try another one. Here we have 5 over 4 and 7 over 8. Now they look like they're proportional because they're both adding 1 from here to here. Actually, this one's adding 1 from here to here. So on a test, more likely people are going to guess and say they are proportional. You don't need to do that. You need to actually work out the problem. So we have 5 over 4 and 7 over 8. Well, 5 over 4 cannot be reduced. It's just 5 over 4. 7 over 8 cannot be reduced. It's just 7 over 8. So since these are not equal, then these two shapes are not proportional. Alright, let's go on. To the end. That's it, folks. I'll talk to you about proportions tomorrow.